Hey,
Hey, what's up?
good morning. Yeah,
Morning, good evening.
good evening. Yeah,
Okay. Yeah,
need
what's
some
up?
beer. Not beer time for me yet.
Yeah, I don't drink beer. I don't like the taste of it, but I have to try. I periodically try to taste it, but I didn't like it in the past.
Yeah, okay.
A
Yeah.
whiskey,
Oh,
wine.
you're
Uh,
you're a whiskey person.
yeah, whiskey, wine. Mm,
Whiskey wine. Okay. Okay.
uh, but that happens rarely, occasionally. Okay, rarely to occasionally. I don't drink that often.
Yeah.
Mm. Yeah. Hey, Aaron.
Yeah. I'm
Good morning.
frantically trying to finish up some stupid hack before
Mm,
I forget what I just figured out.
mm, mm.
And ah, yep. All right, I'll set this aside, come back around to it.
I've definitely had days like that where it's like, I need to leave. I'm going to throw a not implemented error and then put a giant comment right next to it so that tomorrow when I start and run the tests, it'll bring me right back here.
Yes. Yeah, I do that all the time. How's your little one?
He is snotty.
Mm.
He's been breathing and you can hear that.
Yeah, yeah. Yep. Sounds familiar. I think that's
Mm.
entirely par for the course. Here I am. That's what I was trying to do. Yes, I was busy writing my
That's what
tiny.
little kids teach you is it's entirely possible to be very cute and very gross at the exact same time.
Yep.
Mm. I'm getting late for kids, maybe. I'm 34 and I'm getting late
Now I
for the podcast.
see. Well, you have to start with, the other half first.
I got the other half, but we didn't finalize the deal yet.
Ah, okay.
Mm.
I think I'm missing part of this story. Are you engaged?
Yeah, I have a girlfriend for 4 years, but we are not engaged, and there's no wedding. There are plans though, but I have to finish the house first, and then
Oh,
and
that
then
might be a while.
Yeah, I
no
feel like
what
some
um,
uncertainty got poured on that country.
no no. I don't plan to finish the whole house. I will build a house in the semi-final state, if you will, in order to just finish the first floor in order to move in, and then it'll be maybe 2 or
Sounds like
3
a plan.
years. Yeah, because if I wait to finish the house, well,
Yeah, let's say, yeah. Waiting forever. Yeah. No good.
mm, mm, I'm semi-final on the grounding on the zoning rules, though.
Oh, nice. Okay.
Yeah,
Yeah, fun.
maybe 2 or 3 months. Let's fingers
Oh,
crossed.
well, knock on, particle board.
Yeah. And I have to take a permit to to make a plan for the house in order to take the permit. Because if I don't take the permit in, let's say, 3 years, the zoning rules are reversed. Mm.
Right. Yeah, right. Okay.
I
Noted.
don't plan to wait 3 years to ask for a permit though. It's hopefully will be this maybe April, May, June will be a good time to start.
Oh, crap. I'm over here recording. We're like talking about houses and kids and stuff.
Yeah, well,
No, not this one.
hmm.
What did you do? They changed the buttons again.
Do you use any editing software or you just start it and stop it? And
Hey, it's Coffee Compiler Club. We're here today to talk about compilers and language runtimes and typing systems and Georgia Tech football and home building in Eastern countries and I don't know what all. We rambled a lot and failed to chop the video up front, so I might edit it later. Anyhow, everyone's being videoed. You'll be up on YouTube within an hour. And that's it. That's the done spiel. I'll throw out an AA update because I dumped my brains into Discord. and wrote a tome. Basically, I've got the 90% of the theory bits working on the core. I think it's 90%. Maybe it's probably closer to 50%. Except that I've run up against the sort of the next obvious thing that I just didn't test for, which is how to use overloads in a sentence. Like the theory side, I put together some cool examples and it all worked. And the first thing that happens on the main side is I start by pulling them out of every primitive everywhere and using them much more aggressively. And that turned rapidly into, yeah, I'm doing something stupid here. And then I had a long discussion with, I'm gonna say Jules Jacob, about Haskell's use of the equivalent feature, and decided that we had landed on the same page and that I probably shouldn't try to get any more aggressive because the Haskell folks clearly have tried to get aggressive and then backed off. And so if they can't do it, I'm not thinking I should try too hard.
Yeah, the Haskell folks have put a lot of work into their runtime. They're definitely not lazy.
Yeah, right. Yeah. I would, yes. And they've been around a while. So like things that they tried and didn't sort are red flag for me. Right. And what was the main issue? Oh, I don't know what the main issue is. The main issue is I cannot, or I am not propagating overload behavior more than exactly one layer, which means that if you have a function which returns just evaluating a primitive with overloads, immediately the function wants to take overloads and evaluate them. So the function, under the hood is actually doing one of an int addition or a float addition. That's the overload right there. And I'm not pushing it out of the function. And so immediately, if you have nested stacks of primitives, I demand they all obviously type up front. I'm not doing type inferencing even as basic as what C does with just widening. It's just bad. So anyhow, that was.
So does that like double the whole call chain? That
yeah,
there's an int and float version, and then there's an int and float version of the thing that calls it, and an int and float version of the thing that calls that, and that just sort of propagates out.
Yes, that's what happens in Haskell, and I know how to do it, and I wasn't doing it because I didn't think I needed it, and now having written larger than a few sentences of primitives, I need it, obviously, and so the go around was, what did Haskell do to see if I have a clever answer or have to do my stupid answer? And I think the answer is my stupid answer is identical to the Haskell stupid answer, so that's the answer.
At some point, does that become a code bloat problem? Would you rather say I'd like to have a runtime check at the bottom and not have this thing propagate up?
Oh, I see what you're saying. Code generation. No, the obvious code generation will be to specialize. And for the primitives like that, there's an obvious specialization because there's only a handful of arguments and you'll just do the math and specialize the tree. If you fail to specialize the tree, you would have to test at the bottom. I'll specialize the tree. That's not hard. I think in the more general case, you'll end up specializing until you have things with a reference as their base. So pointer to struct, pointer to whatever, and then you'll go to a vtable behavior, which is what Java does. It's all primitives until you do object, and then you got a vtable and you don't care anymore. That resolves the overload at that time. So,
I was just thinking, I have a vague memory of C++ getting into a pathological case of if you've got a ridiculously large data structure that's got a bunch of unions in it, and those have a bunch of unions in it, and those have a bunch of unions in it, you can get the sort of combinatorial number of types at the top.
That for the template?
Yeah.
Oh, the template guy? I know the Julia project I worked on for a little while doing that database had some behavior like that. They got combinatorial explosion. But they were forcing larger value structs out of collections of fields. Like they weren't saying, this is an object that happens to have the following fields. They said, this is a value and I'm cloning it by value and I'm copying the whole value, and every function call has to take it instantiated with every possible piece of the fields. Suddenly they had, 200, 400 copies of the same functions. And that was ludicrous code bloat, and they were killing themselves.
And you don't think this is going to fall into that problem?
Well, I'm well aware of it, so I will make an effort not to fall into that problem. Yeah. See the thing here, AA update. Yeah, short AA update. Yeah, it's actually like the actual coding for getting it into the main, what I call the main code base, has been nice, because I rewrote, like, the thing I did for the theory only side was basically throw away all typing info from Java and use strings and hash tables for everything, like JavaScript, which is really nice for being flexible and quick to throw together and change and add and subtract things, and sucked for performance and sucked for any sort of safety. So I did run into the, limiting, like writing in a large Python app, you run into the you don't have any types. So, at some point you just die the type error death all the time. And I was heading into that zone. Rewriting it with like actual types and type fields and subtyping and structure, it's so much nicer than my theory hack piece. So that part's been going well. And I don't know what else. Other than that, I just have, normal house news. The storm cleanup is still in progress. The number of landslides that have been cleaned up is amazing. And seeing whole hillsides have clearly shifted 10, 20 feet in one direction is kind of interesting to look at. That's a decent AA update. Unless you want to talk type theory on why I got stuck on what I got stuck on.
The thing I was curious to talk about was different philosophies of to what extent you should be able to grab an object that is deep inside somebody else's code and change its behavior slightly. So the example we were looking at is we're trying to build the /stats.htm thing that just gives you a bunch of data about what the server's doing.
Yeah.
And in Java land, it was pretty easy to do things like, oh, go ask the runtime how many file descriptors are open. But if you move that to Rust and you're like, oh, hey, Rust, how many file descriptors are currently open? There isn't really a runtime to ask that question. And the intuitive thing that you want to do is like, oh, I'm going to go put a wrapper around open socket and open file and other things that consume a file descriptor, and just make a thing that counts every time that is called and counts again every time that is freed.
Isn't there an
But
OS
you're
call for
importing
that?
lots of other libraries. So like, should you be able to wrap open file and change its behavior for your whole application? Or is that going to cause complexity for people because they can't ever have a performance guarantee of any function they call ever, because someone under the hood could have grabbed their nice fast function and added super slow metrics to it?
I would have said for the file handles, you should grab, some variant of IOStat and ask the OS what the hell's going on. But the general question of, if you have no performance guarantees, and mostly no language ever does, there are some, I'm going to say, hardware languages that, obviously do. But if you're not in that domain, you don't have any such guarantees. So yeah, if somebody can intercept in the middle, they can. And then if they can say, and also sleep for a century, fuck, you're dead, right? Log a terabyte of data every time you read a byte, and why is my system slow? And that happens in Java all the time. Hey, I called log4j and dumped a terabyte, and I had to make it a rolling thing because I ran my disk out in 5 minutes, so it rolls over gigabytes a second. And why is my server slow? And why is it doing endless IO?
I mean, that's what started us here. Is we had a server at work that's like all of a sudden fell off the cliff and was 1,000 times slower than it was before. And it's like, well, you're only using 10% of the memory and you're only using 2% of the CPU. And it's like, well, why did you stop?
Yeah, and what it turned out to be logging.
Well, so the first thing we found was we were getting file handle exhaustion.
Right. Was it logging?
No, it was opening very large numbers of network connections.
Oh, okay, fine. Yeah, you heard my story about Hotspot putting in a GC wrapper hook to eagerly finalize file handle things.
Yeah, and I've hit that problem with Python once too, that it didn't give you the file handle back until it GC'd. So if you weren't consuming enough memory, it would never give you the file handles back.
Never, and you ran out. Yeah.
You were out of file handles, but it still wouldn't do a GC because
Right.
there was no memory pressure.
Okay, right. And we had to force Hotspot to do a GC there specifically to get those back just because it was stupid. Yes, and that's because file handles on finalizers are a bad idea.
Does System.gc work at all?
The default behavior has changed repeatedly throughout the years. So in the beginning,
and it depends on the JVM implementation too.
It ran a full GC cycle.
That's
then
nice.
It was abused by many folks who then complained about performance. So it got turned off or turned into an advisory, maybe sort of start one after a while. But I just did one a millisecond ago, so don't bother. Then it became command line flags that changed its behavior from always do it when I tell you to do our current default otherwise, which is wait a few seconds before you run again, or count GC things. And then it became the file handle and a couple other system resources were counted up and decided that we have a bunch of finalizers and we should run anyhow just for finalizer's sake. And we can shortcut some of the other things that we might otherwise do because our goal here is to get the finalizers out. And so its behaviors like flip 3, 4, 5. I have no idea what the current default is. The correct answer is don't depend on finalizers. And that makes your file handles need to have a scoped lifetime exit reclaim on them. What did you guys end up doing to solve this, Aaron?
Our current situation was we added a bunch of logging and then had something go read the logs to calculate the statistics on what resources were being consumed.
No, I meant the Python out of file handles, but the logging things.
Oh, no, the Python out of file handles, we ended up wrapping every single time we opened a file in a with statement because that gave you the opportunity to run code when the scope ended. When the scope,
yes, right, okay. Yeah, in the land of C++, that was how Hotspot did it. It had a destructor on everybody who had an OS resource.
Yeah, so our answer was just, call file, close sometimes.
Yeah.
This is another area where I like the container model, where your resources are all managed at the container level, so you always know who's asking for them if you need to know that, you know how many there are.
Oh, one container can ask another one for resource consumption.
Well, for example, container wants to open a file, it can't open a file itself, so it has to ask for the file to be opened, and the thing it gets to ask that comes from the container above it. So you always have the ability in exactly one spot to override that behavior.
So if some high-level guy launches a bunch of low-level containers who launch lower and lower, and there's turtles for quite some distance, and the situation got complicated and hard to track, and somebody starts asking for file handles across 5 and 8 containers way down, and they keep going up to somebody who's counting file handles, how do you manage the situation where you have some set of, I want to say, poor container behaviors where they're just abusing, I need file handles, and somebody else who also needs file handles is like getting starved? Like, what's the resource management strategy amongst?
Yeah, if I want to say this XDC container gets no more than 12 file handles because it will take them all if I let it.
Yeah, I mean, so keep in mind that we're designing it not for massive depth of containers, although other use cases could need that, but a much broader array of containers. So we have a concept of a kernel container whose only job is to start up some basic services, and then because the first container that exists has access to all the OS capabilities that are configured when you start the container, its job is to do nothing because it's hard to mess up security if you do nothing. Like, all security holes are because you try to do something. So the less you do, the less security holes you have.
Yeah.
So the kernel container creates the subcontainers that each have an individual purpose, and one of those containers is called the host. And so it's creating the account containers, and that could be thousands. So it's an array. It's not so much a deep tree as it is a wide array. And yes, it has to manage the IO resources across all those. In fact, It has to know how many bytes of memory are being used at any given time, how many CPU cycles are being used, and how many files are being used, and so on. The deeper you go, obviously the costs accrue. If you're watching this stuff at every level, the costs accrue linearly based on the depth. So, and there's no way around that. Like, it's just reality, right? So if you have a container that contains a container, contains a container, and that whole tree, everyone is focused on keeping track of the resources under that container.
Yeah.
Then there's a linear cost aggregation model.
Yeah, I get that. I guess I was asking what strategy, if any, you would do at any particular layer when you had fewer file handles to hand out than containers below you were asking for.
Yeah, I mean, there are basically two choices. One is that you limit, you put some limit on the number that you would give out, and the other is that you virtualize the file handles. So what that means is that, and by the way, there are versions of Java that did that early on, because Linux would crap its pants if it had more than 60 file handles open back in the 90s. And Windows couldn't handle more than 1,000 file handles, if I remember correctly.
Yeah, I remember there were short limits there. Yeah.
So did that mean you had to play a multiplexer game of like, oh, yes, I'm going to close this file and flush everything out and then reopen on the other side? And
bingo, exactly. So you give a file handle that's not a file handle. So internally you have a file handle, you connect the two, but when you need the real file handle back, you keep this fake file handle that the app is holding on to, and you simply transition to no longer actually has a real file handle, right? So you, so
and as long as I'm undersubscribed, it's cheap. And if I'm oversubscribed, it's expensive, but expensive is better than dead.
But keep in mind that operating systems have gone from really, really sucky 20 years ago, including Solaris, including AIX. They were brittle, they were awful. Solaris could handle, I think, 8,000 files or something, 4,000 files back in 2000. Do you remember Volano Mark?
Oh, yes, I do.
So he tested the JVMs, and basically he would publish on a monthly basis at what point he could kill them. And there was no JVM on any operating system that he couldn't kill quite quickly just by opening files, creating threads. Archer, I don't know if you have any experience, if you have any recollection of any of that, but this guy, Mark Volano, I think was his name. And he would basically do these torture tests. And, Windows and Linux were competing for how few threads they could support before dying, how few files they could open before dying, and so on.
I think one of his
tests, he basically shamed everyone into fixing their operating systems. So within a year of him starting publishing the Volano Mark, Linux went from like 60 threads to like 60,000 threads, like in a year. It was just amazing how fast they improved. And Solaris was always the most stable, but it was also the slowest to grow its capabilities.
To play catch up there, yeah.
Yeah.
Well, I want to say it was the Volano Marks. It's one of those spawned so many threads that the JIT thread would get starved, and the entire Java benchmark was running interpreted because there was no thread priorities on specifically, I want to say, Linux. Every thread had a priority that was box level. And so in Macs, unless you were root and did a raise your priority above the normal non-root Mac. So unless you ran a JVM as root, the JVM couldn't give the JIT thread any more priority than it could give any other thread on the box.
And that's because at the time, Linux actually didn't have threads.
Yes.
If you remember, Linux only had processes.
Yes.
So when you started the JVM, every new thread was actually a new process because it used process fork.
Right.
My memory sucks. So,
yeah.
But yeah, they were all processes. So if you had top, you'd do top and you'd have like 60 pages full of processes because you're running one JVM. You'd kill the JVM. It'd go from 60 pages to like 5 lines.
Yeah. I lived that era. Yep. And figured out how to get we ended up throwing in, what the hell was it? I know at sometime in Azul, we did a enforced duty cycle with locks and blocks on mutator threads. to give space for the runtime, the GC and the JIT threads to do a thing.
The other thing I realized is quite how many runtimes modern software is running on top of, where you're like, oh man, we're out of file handles. Okay, tell Node that it's okay to have 1,000,000 file handles instead of 1,000. Oh no, we're out of file handles. Tell Linux it's okay to have 1,000,000 instead of 1,000. Oh no, we're out of them. Tell the AWS hypervisor it's okay to have 1,000,000 instead of 1,000. Oh no, we're out of that. Tell the load balancer that it's okay that you have 1,000,000. Okay, now you can have 1,000,000 sockets open.
It's turtles all the way down, but it's a lot of them. Way more than seems to be usefully done here.
I don't know
I'm
if our
reading
language design can
Matt's-
help
hey,
us
put
with our
that-
too many turtles.
Is that link in the docs, Matt? Let me go look here. There
Yeah.
it is. Yes. Okay.
The scary one.
Yeah.
I think I missed the thread of the conversation. What's scary?
There's in the chat now in the doc, and it was we go roll back to what I was doing in AA, and I don't know, but my theory is I'm going to force anybody who is like a raw primitive to specialize to the point where I can inline the raw primitive. So the hard guarantee is all raw primitives get inlined. They're fully functional, type as a first class, blah, 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 have all the great functional goodness. But if you call a primitive like you call a primitive, it will get inlined. And then I will force specialization as necessary to make that happen. And then the question is, how much code does that turn into? And that's this comment with exactly templates doing the exact same problem we were just talking about before we got into file handle limits. And hoisting to members to base classes and instantiation penalties. None of the methods are made virtual. No runtime polymorphism. Right. I don't want to do a runtime check for to call a primitive integer add. I'm not doing a runtime check. And if you look at the Haskell num type solution, I think he eventually boils that down to the same story. Everyone's a num. Num supports ints and floats and adds of left and right of both. There's no hard language guarantee that you don't have polymorphism there, but the obvious inlining turns it around, and the runtime compiler for Haskell makes a best effort, which is in general successful. And I want to be able to say, here is a hard guarantee of inlining for this behavior. Like if you do operators, like you're doing operators, like you don't overload any operators and you only call int, add, and subtract using the normal int operators, I hard guarantee they'll inline. Design goal, not implemented, obviously, and I think that shouldn't cause giant code bloat. I guess there's some theory that says if you have a bunch of the same function called with ints and floats intermingled in odd ways, you might get a couple copies. And in theory, you could get some exponential, 2 to the n for n count of arguments.
Yeah, I was going to say, if it doubles all the way down, that's fine. If it combinatorials all the way down, that's more problematic.
No, I think it doubles, but you have to write very specific code to make that happen.
Or a compromise, you choose the largest type you can fit. So if it's short and ints and longs, you choose the longs.
Right, and then there's the compromise, which is always, as long as you're not dropping any bits, you can inflate, as long as you're growing the size. In some cases, it's just like twos.
Yeah.
Ints and doubles.
Yeah, that's why I was making... Sorry, go ahead.
Go ahead.
I was making the argument that it's because you use lattices so much in AA, I was surprised that you didn't add a unsigned int 53, signed int 54, unsigned int 63.
Right.
So that all of those would be nodes in your lattice. And you could be like, look, this just is an int 53. I don't care. I can generate whatever code in context based on whether it's interoperating with floats or ints.
That's an easy thing to add later. I put in enough variety to know that I was banging around and hitting interesting cases, but I didn't need every possible value there, because they're all mechanical at that point, right? Once I have 2 or 3 copies of int 8, 16, 32, I can add another one by cut and paste, right?
But yeah, it seems like when you start doing a lattice thing that you want to have that unsigned int 63 because it's the intersection of the signed int 64 and the unsigned int 64.
Yeah. I'm actually of the opinion that the signed unsigned thing has a little bit of a use around network bytes, and for almost everyone else, they don't care. And so I'll make sure network byte handling works well. And other folks, you know, there's a storage class for space. That's important. I'm chopping you from however many bits down to 16 or 8 or 64 because I have a billion of you and I need to know. But if I'm doing math and you think that you're loading 8 bytes, but I do all the math in 64, no processor performance impact will be visible by anybody. And it'll all round off correctly, and then I'll chop it to whatever you're going to store it to when you're storing it. But in between, it had more precision than necessary, and no one knows and no one cares. And I think, Cameron, you were talking about that earlier for the same exact thing, or you and I were, a week or two ago. There's a lot of options, but as long as the precision is greater and nothing got dropped, no one's going to tell.
Right. Yeah, so semantics, you want to be able to guarantee the behaviors without exposing the mechanism behind them.
Mm-hmm.
Okay.
And what guarantees do you give? And your comment from your code was very telling about widening. That was a really nice example. Widening intermediate results.
The floats. Oh yeah, the right.
Bytes and sorts.
Yeah.
And overflow, and pointing out we'll just widen everything such that we maintain the most precision of the end result that you expect.
You want me to show that here?
Yeah, I think that was a good example because it shows that you can write such a thing, and there is a semantic difference. So you have to declare what it is.
Give me the share screen and I'll.
Oh, let me hit the share screen. Hang on. Stop that. Okay, now try.
Sure.
And the other one is we can throw it into the docs, but I think you just link to it's fine.
Yeah, so it's everyone, can you see that? So it's this this annotation auto. So just to explain, because I didn't really explain.
Well, let them read the comment in the middle, or sort the comment out easier because it's a really nice.
I just wanted to explain this. It's imported automatically as auto. So when I talk about at auto, that's the it's this mixin I'm talking about. But it's basically just used as a marker. And it allows the compiler, because we have only 2 types of tests, if you will. We have an is a test and we have an is assignable test. So let's say I say A equals B. That means that B has to either is an A or is assignable to, which is either is a or has a auto convert. And let's see, that's the.
Well, I'm talking about the paragraph that says the non-obvious reason.
Right, exactly. So, and this was fairly complicating in the compiler itself, right? Because you can imagine kind of translating that text to code. I always hated this in Java because I always would have to add not 1, but 2 conversions to basically every line that would have any mixed types in it, right? So it was like, how do you solve it? And it's basically you want the conversions to happen early if they're automatic, because conversions are necessarily non-lossy, right? Meaning I'm going from an int to double or something like that, right? So the conversions that are allowed to be automatic are the ones where you don't lose any data and you probably pick up space for data. So if you're multiplying 2 bytes together, right? To form a unit 16,
yeah,
right? So it's going to be a uint16 when you're done. So the first thing you do is convert n1 to uint16 and n2 to uint16, then multiply them together so that the calculation happens with the largest possible space instead of doing the conversion last.
And your
Yeah.
example there specifically overflows.
Right. Exactly.
And
so you'll
produces the
see
difference.
this, like if I pick an arbitrary, let's say uint64, right? So I'm going to pick a uint64 and look at its conversions. And what you'll see,
You have to stop scrolling at some point.
yeah, sorry. Like a uint64 can't automatically turn into an int16. And it can't even automatically turn into an int64 because we give up the last bit,
Yeah.
the last power of 2. But we can automatically turn into an int128 or a uint. Obviously, a conversion to uint64 is free. Let's return this. But a uint. So as long as I'm not losing precision, I'm allowed to automatically convert, and that was the thinking behind the auto conversion.
I'm going to respond to Matt's comment in the chat. If you are intending to go to custom hardware with a narrower precision, I still think it's reasonable that the compiler do all the math as if it's infinite precision, and then treat it like a storage class where he chops. Because my experience with most hardware is that they will do that as well. So addition's easy, there's no difference, but multiplication or division, most of the hardware guys will just use an int16 operation there and then chop it back to int8. And they may know that they can throw away some higher order bits earlier or whatever. They take shortcuts, but it will behave just like you said, 2 uint8s, they'll go to 16, and then I'll chop it back to 8 when I'm done, because that's what the hardware is going to do.
And there was a certain point where this really mattered, because a 32-bit multiplication on a 386 was 39 clock cycles.
Yeah, right.
And by the time we got to the core chip, it was half a clock cycle. So you could do you could do 2 pipelined 32-bit multiplies inside one cycle on a core or core 2 or whatever it was called.
Right.
Memory is no good, but so it used to be you'd actually actively pick instructions and test them and so on, and a lot of the instructions that got used the most, just their price went to 0 basically.
Yeah.
So, a multiply used to be a lot more expensive than a memory access. And now inside a single memory access, you can do 600 multiplies, actually more than that on an x86, because you actually have more than one multiply unit in a core.
Just a point, you should tie these two together. So for GPUs, I'm sorry about my mic, I think I can do about it. For GPUs, you are going to imply that your data is large if you accidentally promote to int60, and this is why it's a catastrophic performance cliff. You never want to go from 8-bit elements to 16 elements if you can help it, because all of the data loads and stores are going to double, and it's just brutally reduced performance for GPUs. So this is one of the reasons to stay with 8-bit integers if you can, or 8-bit floating points.
Matt, I lost about 3/4 of that in the bad mic. I think the gist of what I heard was there's a performance loss if I use int8 versus int16 in the hardware because it doubles resources. And I understand that, and I'm specifically saying the extra precision was due in the middle of the operations, and then you would truncate right back to get the size right back down. And were you saying something along those lines? Or are you trying to find a better mic? Damn. All right. No sound.
Yes.
Trying
Yeah,
to-
so we've actually, for this reason, we've actually introduced two different FP8 types, the E5M2 and the E4M3 types from NVIDIA, which is what I am assuming you're talking about here. And yeah, we would, as long as the thing is though, if I have say a float 64 and I multiply it by an FP8, you wouldn't expect that to be done in an 8-bit multiply, right? Because you're obviously going to lose data. And if you're assigning the answer from the multiply to a 64-bit value, again, what we're saying is that, oh, we know we're going to end up storing the result in a 64-bit. So we have a choice to either do it as an 8-bit multiply or as a 64-bit multiply. If we do it as an 8, we're going to lose data. So we're going to choose, even if it's more expensive, we're going to choose as a default to not lose data.
I'm reading a different message from Matt. I think you two are talking slightly different things. Where I'm reading from Matt, and you can tell me in the chat, you're thinking that there's a promotion of the results, which is then stuck around in the promoted larger size. And what Cameron and I are saying here is, no, you do the internal math at the larger size, you promptly move it back down to the size that you're going to store the result in. So if you've got two 8s and you're doing a multiply, you can do a 16-bit multiply, so you carry the extra precision bit. But then you've decided to chop it back to an 8, you chop it back to an 8-bit thing, and then you lost some of the high order bits. But if you do two 8-bit multiplies, in 8 bits only, you can get an answer that overflows and loses some precision that you would have otherwise kept if you did a 16-bit. And the difference there is a very small amount of hardware to keep the extra bits during the operation, but not when the operation's done.
Yeah, what Cliff's talking about is very similar to what Java did with the strict FP keyword, where basically if you didn't use strict FP on x86, for example, it allowed you to do 80-bit precision work and only scale it back to 64 bits on some other set of rules, right? So you could actually maintain a higher percent. It allowed the runtime to choose to use more precise math if it wanted to. And I think that's really what Cliff's talking about. I'm talking about something different, which is I'm assigning the result to a larger value. So I'm actually keeping the larger value. So since I know that the result's going to be larger anyway, I'm going to scale the inputs before doing the calculation.
Yeah. And
because I have to do a conversion either before or after the calculation.
Right.
So I'd rather do it before.
I believe I understand what you're saying. And I'm also thinking I understand that Matt and I are now also on the same page. That the result got truncated down to whatever it did. And but internally the hardware did a larger precision, and the compiler, when he constant folds, has to do the same larger precision hack. Yes.
And Matt, I'll know more in a few weeks because we're actually just starting our ML project. Just kicked it off this week, so I'll know more soon.
So I thought you would have been working on a higher performance runtime, the JIT.
So Mark actually just pushed this past week. He just pushed our first GC. He did a Mark implemented a mark and sweep GC. Yeah.
Excellent. You gave him a broom as congratulatory, right? Yeah.
We just don't have a runtime that plugs into it yet, but we have the GC done.
Okay. Excellent. Yeah. Hotspot went through all these rounds where the GC had impacts on the JIT and the runtime that no one knew. Or the JIT and the run, the GC guys knew, but the runtime and the JIT, me, didn't understand until after the fact. And then it happened again when we went to like different versions of card marking, and it happened again when we had to do read barriers versus write barriers, and it happened again when you do stack crawls in a different way and whatever. Getting that in early is important because it has so many touchy-feely hooks throughout all kind of parts.
Yeah.
So what was your solution? Move the JIT people to sit in on the same hall as the GC people so they would talk more?
We did that already. That wasn't the issue. We all had our large, complicated, in-progress things going on already. And then some other guy down the hall is telling you, no, you have to do this other thing first. Yeah, the we just didn't know what we didn't know. So in the end, what we call the compiler interface, what the JIT had to honor as an API had a substantial hunk of its life tied to GC. The two major compiler interfaces were, when do I blow out a method? How do I record that this method depends on something, that it blows out if the something changes? And then how do I tell the garbage collector where all the pointers are, or they're offsetted pointers by some other value or register or whatever, so that the garbage collector can rewrite the pointers behind my back. And not knowing that we needed those meant that the back porting them in was a giant mess. Going in up front, it would have been a lot cleaner. Same with a read barrier. Like, oh, we have to emit code for the read barrier. Well, there's no hook in the compiler to say, and here we put out a read barrier. And the read barriers all varied over time. And they wanted to be, half of them wanted to have parts that were optimized by the JIT, because I knew things like, this guy's always a 0, or you just allocated that guy. He hasn't been through a GC cycle yet. You don't need a read barrier when you're screwing with him. And half of them were like magical. And here we do a pointer mirror TLB lookup, and don't touch this, Mr. JIT. This instruction is magical from your point of view, right? And so that was always a big mess, because it wasn't well thought out ahead of time. It came as patched after the fact on a large, running compiler.
So I posted a link that reminded me of Simon this week that I saw, because the guy who wrote this is talking about the length of, in Rust it uses FN, and he's like, it should have been called fun, so it would have been 3 letters long, so it would have matched let, I think. I was like, aha, Simon would be so happy to see that.
I use fun for or FCN, function or fun, yeah.
So
yes, yeah, I saw the article. I mean,
what's that?
hard to ignore. I saw the article. Hard to ignore such a topic. Right.
Cool. Any updates on your end with the?
I'm just wondering. I worked a lot on the collection filtering stuff. I'm not sure whether I mentioned this, but I'm very happy that I basically have this type class or trait-based polymorphism or overloading, whatever you call it, so that I can call flatten on a list of lists or on a list of options, and it simply works. And that was one of the nice realizations where I didn't know before whether the language could do this.
Did you make the option collection itself, like in Scala?
Let me think. I think I have a lot of. So basically, the API is pretty much the same, I guess.
But, yeah, I generally like the API of an option is just a list that happens to have a length of 1 or 0.
Yeah. I think I didn't implement a collection. There is no kind of interface or protocol existing in the language. So currently, it's just some things like arrays and lists and options have like the same methods and hopefully like similar parameter types and result types. But that's pretty much it. One of the obstacles there is that on option, you probably want to have your map and your filter and your flat map strict. So it's like it evaluates at every step, because it's like you either have 1 or 0. But the whole collection API should be non-strict, so that you can first build your pipeline and then run it when you're done. And I think, and that's why I'm currently not trying to make them make option and collections like list and set and map match each other completely, because I already know that option will keep the strict API and all the collections will probably
What does
be-
strict mean in this context?
so basically, if you have like this, if you have a long list of operations, like you have a list, and then you do a map, filter, maybe another map, then you have basically two options how you go through these things. One approach is you first execute the map, and basically you have a list as an input, execute a map, have a new list as the output, and then do the filter, receive a new list, do the next map, receive a new list, and then you're done. And the other approach is to think of this map filter map example more like a pipeline where you have individual steps where you put one element through it. And
So you would say strict can't look ahead or look behind.
no,
The
that's
sort of strict, you're only operating on one element at a time.
No,
Causal,
no,
you can only
that's-
operate on the past.
Yeah, I heard a different thing.
no,
Unless-
it's yeah, maybe.
Okay, so you tell me if I got it right here, but what I heard was I wrote in the code map filter map. What I expected the compiler to implement was map filter map, but the language wants to allow me to switch that around, that I loop fusion map filter map and call one loop that takes one element, maps it, filters it, maps it at a time, and does the next one. So one says run an entire pipe, build an intermediate result, run the second pipe to filter intermediate result, run the third pipe. That's the strict one. You go in the order written by the user. The other one says I can change these orders, like a structive array versus array of struct. You're going to turn it 90 degrees. And for one element, I'm going to do map filter map. Typically, that kind of behavior is usually more performant because you deal with the one element all at once.
You save a lot of copies.
They're
Right,
lazy.
Yeah.
They're
Yeah,
lazy collections, basically.
Yeah, you can think it instead of building a new collection each time, you are chaining a function and building the function which is all its operation and push that function through the collection at once.
So other things that happen here are like shades of SQL query optimization. If you know you have a bunch of filters in a row and you can push them up front,
Yeah.
you'd love to chop fast.
So
That's
basically,
that's the luxury of the lazy evaluation. You can.
And then another similar in this line here of reasoning is to ponder if you're going to allow parallel execution of what are semantically unrelated operations.
They have to
I
be-
guess the question.
Yeah, so like
Sorry.
the SQL query optimization folks at that DB startup I was doing, we definitely, push them filters up front in the query optimization path, push the filters up front and figure out where you can get maximum parallelism, and then that's what you try to
Yeah, and
JIT
if you
code
look
out.
at the Java 8 work that introduced streams,
Streams,
which is
yeah.
basically Brian Getz's project to do what Simon's
Yeah.
describing, 90% of the complexity in the design was related to one thing, which was parallelization. So I'm not saying it's good or bad. I'm saying it is what it is. So trying to make it safely parallelizable was a pretty significant lift in that project. Artur, you were probably there at the time, watching the whole thing. I don't know if you have any comments on that.
Yeah, I wasn't involved, so
Okay.
There is
Sorry.
there is a thing that just says take a look at parallelism and try not to do something that gratuitously denies it.
I've always found the collections parallelization thing. I mean, it's a great technical example, but it seems to be, generally speaking, a huge loss for almost every use case I've ever seen. So
All right. I end up
Except the exception is SQL.
Yeah, well, right. H2O doing big math on big data parallel. I end up hand rolling all my own collection like parallel behaviors. Now, I did it before streams is around. Was stream to me as performant as what I ended up with? Should I have skipped over to streams? I don't know. If you're not using big data, yeah, the parallel effort's no good.
right. Yeah, I mean, that's the it has to be big before there's any payoff.
Yeah, right.
Mm.
Yeah.
So the fact that you were doing big data is kind of the giveaway why it would be an awesome thing.
I think one of the problems with parallel execution of that kind is that it introduces a lot of complexity. So I think it's a fine thing to prototype with, saying, okay, I want to have sequential and parallel operations, but you should only implement the parallel operations to figure out whether your sequential operations are robust against various things, and never ship it to any kind of outside user. And I think the one problem this parallel execution has is that most APIs usually don't allow you as the user to pass in the interesting bits of information that you know about the data, maybe that would help parallelization the most. So it's always this, yeah, we switch on parallel and now it takes 8 cores and it's 30% faster or something, which is like I think that were the performance numbers when Scala did the thing, which was of course catastrophic because they had strict collections and then did parallel on top of that. So imagine basically the slowest way to implement anything, because it's like it's not even parallel. It's like you have like this
I get it.
because your individual operations are strict. It basically says, okay, you have this map call, and inside this map call, things might be parallel, but this map call has to be finished and return a resulting collection, because you can then start the next parallel step. And I mean, the performance improvements compared to sequential were not even, it's like not worth speaking.
Not to mention concurrency.
Some people got to write some really nice research papers about it.
Right. No, I'm suggesting look and see and decide that, there are API choices you could make that would make it much more difficult, like demanding strict.
Yeah.
Because immediately, as you said, I have to get the collection made before I can start the next one up. And that's a hard kill on performance because you don't get enough work done in the one collection.
Do you have immutable state, Simon, in core?
Yes, I'm not doing anything special there because I haven't really thought about a problem domain and what are the things that can be done reasonably and at low complexity. And I mean, what I've been playing with is saying, okay, the runtime or the compiler has some straightforward way to tag existing data or existing type definitions as immutable. So recursively immutable in that sense, saying, okay, I have this class definition and all its members of this class are immutable, so I can mark this whole thing as immutable, and maybe based on that some collection library or some concurrency library or the runtime or the garbage collector can do some smart things, but I haven't really evaluated whether it's
not maybe it's required. The discovery of immutable severely defines how parallel you can be, because that's concurrency.
Yeah, I mean it's in the end it's a trade-off. People will write code anyway, and if the code happens to be immutable, there will probably be less bugs. But yeah, basically the idea is code will be written either way, and I'm unsure whether I can provide help from the compiler or from the language runtime to write code more safely, and I have really no idea about that. So yeah, I mean, it's a long way to go. The core language still has has a lot of syntax stuff pending, a lot of semantic stuff pending, a lot of standard library stuff pending. And I mean, at some point, I also want to try my linking ideas. So I mean, I have like, I have enough work until I'm dead. So I'm not worried about that.
Cool.
Yeah, Matt and I are in the chat talking about loop fusion and the direct correlation and the difference. I mean, I worked on compilers that did loop fusion as part of their core offering, and then they tried to infer when it was correct and when it was safe and profitable and all that. And what I did in H2O was just make it easy to fuse loops by hand, but the user picked which loops to fuse.
Well, do you want to share your Google Docs screen? Maybe then.
I can. Hang on.
Let me see.
We should be sharing Google Docs now.
Nice. So,
where are you writing code here? List.
So basically, if I have a few benchmarks to judge other people's collection APIs, and always looking at stuff where I say, okay, this is not non-strict enough, and why are you evaluating this, and so on. And one of the examples I have is something like this, where you okay, let's say you have a list of let's see, say you have a list of no, that's a bad example.
Well, don't fill in the list. Just say something about, I have a table of country names and something, and that's fine. We get you.
Yeah. Okay. So the idea is to say, okay, I have some kind of group by operation, and usually this group by operation returns a hash map with a key and a value. And my argument is that it should return absolutely nothing except like streams of things that could be evaluated. And the reasoning is this: if I have like have some data, do a group by and say, okay, I have like this geographic data, and now I have grouped it by country, and now my map is basically the key is the country name and the values are the cities, for instance. And I'm saying, okay, if I'm then only access a few of those keys, it shouldn't even evaluate the rest of the keys.
When did you filter? Yeah.
Sorry?
If you only evaluate a few keys, you have a filter running.
Right, but it's a filter that the get on the map actually resorts the entire web and moves the filter to the front.
Yeah.
So that it does a filter, then map, and and then.
Right.
Exactly.
And that's one of my benchmarks. And the other one is, of course, first sorting something and then saying take 3. And saying, okay, this sort thingy should only run until it has sorted the first 3 elements, because we are never asking for more. And yeah.
In the land of the DB work, we did both of those kinds of things, and they had a very large, complicated query optimizer that would attempt to move like your get of the named countries in front of the get group by and crap like that. In H2O, I said, you wrote the kernel of the map and reduce where you fused yourself, but you could just fuse by calling out each of the kernel pieces in part, one after another, if you had a bunch of kernels to go. And then we ran all that at, memory bandwidth speed. So it was faster, lighter, bigger, but you hand wrote the filtering and you hand wrote the kernels. We made it easy to write a kernel, or easy to fuse kernels.
I mean, that's a totally reasonable approach. I think last time I checked, I think Scala is also going that way. I mean,
and in fact, sorted take 3, we had a let the DB land. H2O did too, had a max, take the max in for given in, find the max in values. Just specifically because that one was common.
It makes me wonder. I've seen a lot of code that is lists of dictionaries that ends up in these complicated streams. I wonder if you just build table abstractions as a core primitive into the language, that you'll get some of the SQL goodness and say, look, there's just this concept that is a table, because a lot of times you see the list of dictionaries.
I was going to claim that I wanted to get an H2O style table. One of my reasons I started AA was because of the lack of boilerplate, lack of compiler support for what was basically a large distributed 2D table for H2O meant there was a lot of boilerplate that I would love to have farmed off some other way.
But like, if table is a core concept in your language, maybe group by is not so bad.
Right. Right. And one of the goals would definitely be to figure out a way to optimize the queries that you do on tables, or at least promote it out as so the user can write a query optimizer on a table. And that's like, just make sure your API for whatever counts as a table has a reasonable thing to it. Group by, map reduce. Oh, I see. Are you doing the...
Sorry, I was muted. I think that was the example of saying, okay, we are not doing this elaborate optimization framework, but if people need fast operations, we are just building arbitrary combinations of existing operations, which are equivalent but a lot faster, because we're not building whole collections between each steps. And I mean, this group map reduce is I mean,
well, that's the
everything with it. I mean, a group is even more powerful than filter. It's basically you have a souped up filter, a map, and a fold in. I mean, yeah, you'll see it. I think it's fun.
So it's interesting though, Simon and Cliff particularly, is that with the group by get, you can imagine all day long having your hotspot like implementation trying to iron that sucker out into the very most optimal code. But at some level, there's one piece of data that's not getting to where it needs to get. And that piece of data is, hey, I just did this group by 100 million times today, and each time they only called get once, right? Like there's this like hotspot, if you will, does it at the code production level, but here you actually need a heuristic fed back into the library. How do you do that? Like I've never even.
That's internal profiling based on the startup I was at. They were doing that in spades. Yeah.
But I just want that one line of code to get that heuristic. Like, hey, this line of code that got executed 100 million times. This line of code.
Right. You send those lines of code into a query cache. Totally. And you gathered stats from the last time the query ran in the query cache along with the exact query. And there's questions now about subqueries and can we cache the subqueries? Yes. And do we gather stats on them and the like? And it's just like a code generator in Hotspot. They're taking queries and subqueries and groups of subqueries and caching them along with the current optimized query plan that you would promote to hand off to the DB and the stats you gathered, which, waffle around which kind of query you're trying to do or whatever. Yes.
I think IDEs or linters or even the compiler itself should simply warn about such patterns. I mean, there's clearly a better way to write this, so there is no point in not telling the user that. And
that's a different one. You have, Well, I don't know. Does SQL folks have an IDE that does SQL optimization and hands them suggestions like IntelliJ does on Java?
Snowflake does that.
Ah, okay. Yeah, that makes sense.
Actually, Snowflake is only too glad to have you burn more cycles.
Yes, well, this was a direct competition to Snowflake intended, so there was some effort to be efficient.
But the thing is, Simon, at some level, I really disagree because this is a library we're talking about. How's the compiler supposed to know about a library and tell you not to do that? Like, what you really want. Sorry,
No, I think you have a linter, and that linter has settings or a policy file or something, and can just tell you, okay, if you're using these types and these methods, you're probably doing something wrong. I mean, Rust does the same. So I'm not too worried about that.
It's almost like you want to be able to say something like, using profile, open curly blah, right? And then have somehow that profile feed back into the library. So basically take advantage of the capabilities that the runtime has for profiling.
But why isn't that same capability let the runtime get at that profile when he sees the thing he profiled come around again? Like in the land of Java, the bytecodes and the methods come around, and so you see the same method again. So you internally grab the profile that you had before and you start bumping it again. So somewhere in here, I'm handed a query or a group by and a map or whatever. And when I come in again, I'm going to say, well, I'm going to go group by again.
Yeah, I'm just kind of wondering if there's some way, because it's a scoped profile, right? It's like within this block of code.
Yeah, it's scoped.
But I don't know if that's something that should be done at the user level or at the runtime level or some combination.
Well, I'm trying to say that it can be done like if you're doing it at the library level, you could just do it at the library. The user doesn't have an API where he manages a profile object unless he's doing what Arthur's doing, and you're trying to pre-cook profiles that you're going to start up on another execution, in which case those profiles become an OS object, and they have to be handed about as an OS object, a file with profile data in it. Right. So
this is a good territory for autoencoders because you really, you suffer from maximum cache degradation from group bys specifically. But an autoencoder would be something to at least, take advantage of what it sees in regions and vicinities of access.
All right, I'm not clear what an autoencoder is doing here with group bys. Like I'm certain that the group by map reduce and the group by split into that followed by map reduce, I know how to do like that. The efficiency of that one can be insanely good.
Yeah, I kind of know what I'm asking for, Cliff. Like if I were a library developer, I would want to have some, let's call it injectable thing, where I'm like, okay, tell me where the call came from. Give me a token that give me a hashable comparable token that tells me where this call is coming from, so that my internal statistics, I can very efficiently correlate those with call sites. So give me a previous call site token, right?
So in the land of C, you would say I have
underscore line.
Yeah.
Yeah.
I can.
That's exactly what I was thinking, but it's not underscore line. I want to know the underscore line and underscore file of my caller. Who called me?
Well, the caller has to hand it in. The caller could.
What I'm saying is it would be useful to. Do you know what I'm saying, Simon?
Can you not learn that by reading your own stack?
You can, and then why profile at that point? Because you've now spent 600 milliseconds looking at your stack for a 1 millisecond call. Like you lose every time, especially in Java.
There's a security thing about looking at your caller,
right?
But I think it's fair to have an easy call syntax that says and pass along my program point, my uniquely identifiable program point, so that you could use it to say something about unique callers coming in at me.
So Tidor, doesn't Scala have some sort of implicit parameter, implicit argument thing that it has? Because that's kind of what I'm talking about. It's like you want to be able to say, I don't want to put this in my signature, but I want an implicit piece of information picked up
That
from
does.
the context.
That does what? That does.
I don't know. Yeah.
That does what? The implicit argument. What would change the behavior of what?
What goes in implicit? We're just asking if Scala does this thing. Tell the callee who the caller is via an extra argument. I thought implicit was an extra argument.
Well, it is. I think what
it's-
Scala lets you do is kind of attach context via an implicit or
Yeah,
something like
yeah.
that.
It's not in the language, but Lee Hawi has a library that does what Python does. Identifies at which one, which file, which method was called. I don't remember the name of the library, but it's not in the language for sure.
Okay. So
Yeah,
what you're
I've
saying,
seen weird Python hacks where it's like, call this function and it will return to you the name of the function that called the function you're in, because it walked up the stack and read the
Right.
name, and you're like, oh my God.
right?
You
Right,
can
so-
do it with macros, though. I believe so.
The caller can do this for almost no cost. He can pass in a token of almost no cost. The equivalent version of that is the callee is allowed to peek the return PC as an opaque token. He can hash on it. It's guaranteed to be unique. I see Cameron just snap to that one. You guarantee.
And the JIT should notice this is happening and reverse the two, so you use
Yeah,
the cheap
exactly.
one.
I was.
Well, I mean, suppose I hand you a language syntax that said, here is a magical token, which is your caller, and I implement it by just handing you the return PC of the JITted code.
I'm wondering why I never tried that in C. Now that you're saying it, it's like it's so freaking obvious. Like,
Okay, well, magically Hotspot does that very thing and does the mapping on the return PC back to where the counts are going so that he can tell you all kinds of shit. That's exactly how that works. Now that goes hand in hand with the stack crawl. You grab the return PC, who's my caller, what's his stack size look like, where's his offset, and then you get his return PC and you can go and go and go. And if I just make it an opaque token, what you do with the token is you can guarantee it's unique from your caller, and you can, I could probably hand you a reverse mapping to the source code. Oh, there you go. Theodore, put these things in the Google
But you
Docs,
better have
too.
some runtime support for that if you want to do that without a security bug.
Right. Well, the reverse mapping is just, here's the source code, which, you have to agree that the guy has to, the whoever put together your jar or whatever has to agree to hand out the source code to you. If you don't have source code, I can't reverse it. I can only hand you bytecodes in the Java land.
What does that
And-
become? Like dwarf data for the debugger?
I don't know. I don't know. This is, we're in a new zone here. In Java, I know exactly what to do because I've done it before. For AA, there is a security thing that says who my caller is. Then you know something that you can't otherwise get, and that could be turned into some sort of a security issue. But if the caller says yes, the callee, the guy I'm calling, is allowed to know that I called him, and at that point you could say, effectively, the caller agrees to hand you a magical token that uniquely identifies that call site. And then the implementation could be, as I said, as cheap as grab the return PC.
It would be tempting to me to throw into that debug information that describes the source, a URL
sure.
that says, go to this URL to get all the source data and post to this URL with all of your metrics. And if you want me to care about your performance sucking, upload your metrics to my server so I can see who's calling
That's
me.
an interesting thing. That's a whole nother ball game. Hey, as part of a performance counter, we're going to stop and do a bunch of web user interface and web GUI things that you want to gather your stats for a while and make the call. But you're saying allow people to push uphill toward.
Right, I'm saying it's the debug data. It's just a constant string that's in your binary somewhere that says, hey, by the way, if you want the source map, here's where the source map can be found, and here's where you can push your metrics to.
No, I think that's fine.
And then someone offline, they collect data for 4 weeks and then bundle it all up together with all of their counts per line of code and send the thing up to the person saying, hey, I actually care about how your library performs. We've got plenty of NPM stuff so that I can pull down from people it's kind of hard to push your performance metrics back at someone and be like, hey,
Right.
controller of this NPM name, here's where your thing is making my thing slow. Please.
Well, then you have to run a web server to catch it, which you can do. But that's an interesting infrastructure decision. Shareable performance data. You can opt in somehow that I want to share my performance data.
Right. And it can be the exact same
library.
file for warm starts as for I would like to give something to developer.
Yeah, right. Yeah. So that sounds cool.
Preferably
Hotspot
combinable in some way so that I can go grab one from all of my 100,000 servers and then merge them into one file to send the developer. I don't want to send them 100,000 runs.
You know, Hotspot never pushed the data uphill till I put in that API for letting you look at it, at least, but it kept it internally. He certainly has it. And I always was bummed that you never could easily push it uphill. That's why I put the interface on. Yeah, okay.
But everyone says if there's something you care about, write a benchmark. And it's like, maybe you don't need to write a benchmark. Maybe if there's something you care about, publish your profile data.
Right. You need an opt-in for the end user who has to have a web connection and he's burning some CPU and IO cycles, but you get a free stream of data. Here's a funny one though. You also get a free stream of let's try security word here, unvalidated data. So it's pretty easy to get a denial of service attack where some Yahoo posts data at you that's like full of crap. You know, made up metrics. You're just taking metrics from the internet now.
Yes, metrics from strangers count less than metrics from big customers.
Yes. Well, trusted people. Network metrics from trusted people versus networks from strangers. I mean, metrics from strangers. Blah. Because in particular, it was really easy to get metrics in Hotspot that were inconsistent with each other. And so being inconsistent with each other meant that you got it's like a DOS attack on your shared metrics you're talking about globally collecting shared metrics from across the interwebs for a common hot library. Someone does log4j and 1 billion people call log4j with 1 billion bytes a second. Okay, so you collect log4j, you know, what's a library that's widely used and widely shared? Well, okay, fine. So now what happens if some Yahoo comes in and says, and this point, the answer is infinity, and at that point, the answer is 0 and whatever. And he tries to screw you up by throwing in illegal things. You know, Hotspot had this.
No one would ever do that. Come
Exactly.
on.
Well, I had racy runtime things, so I would get it by accident, you know. Hey, I have exactly 2 subclasses, and they're called child 1, child 2, and child 3. And, you know, the conflict was I had 2, and they have 3 of them. And that happened all the time. So I emitted code for test 1, and it must be 2, and also there's 3. And whatever, fine. Because of racy shit. So you had to deal with that. I'm just blabbing out loud. Now, I like the idea a lot. I don't know how to make it safe, but maybe you just filter sanity and hope. Assume that the spammers are obviously spammy and you can filter them at the website interface. Hey, here's another million metrics being published by folks in Belarus. You know, I ran my web server for a little while doing Rocket real time, and indeed I had every day at about the same time, several thousand bogus attacks from some script kiddie in Belarus. It was always the same web URLs he attempted. They were always for some Python-based cheap ass server that I was not using. So they never did anything. They just bounced, but I had to deal with it.
My favorite one of those that I don't even know if it counts as an attack. I was working at a web app firewall for a while, and we would see that someone was scanning the entire internet in IP address order, and it would hit each customer in order by their IP addresses and would say, are you Nike.com? And they were all getting rejected by the firewall because it's like, this host name is not on this server.
Right.
So I went to the URL to see what was the thing. They were like, and it was like, such and such sneaker will be released in 6 hours at midnight, counting down. And it was a bunch of sneaker scalpers who knew that they were expecting a lot of infrastructure. So they had to put the infrastructure online and test the infrastructure, and then they would repoint the domain name at midnight. But if they could scan the entire internet, they could find the server before the sneakers went for sale and buy the sneakers ahead of the line. And
But that
I'm just
game is
like, man,
this-
that people are serious about their sneaker scalping.
but
Wow.
now this is a whole new ball game. I read about bots that buy sneakers, and that's insane.
Wow.
But my point is, yeah, you're going to get metrics, and you're going to get someone who may not even be evil. They're just doing something very weird.
Oh, I had
And it's
plenty
like,
of those.
it looks
too.
like the vast majority of your cycles are going to this one use case, but it's actually only people mining Bitcoin that have that particular performance profile, and everyone else in the world looks different. You're like, what do I really want to optimize for?
Yeah, the Bitcoin miners can pay me fucking money. Not Bitcoin either.
Mhm. Well,
Maybe Bitcoin. I don't know, but
Yeah.
yes.
why
Right.
not to?
That was, I worked at Sun and I got told, do this benchmark because we're in competition with IBM and they're doing this benchmark and promoting that they're better than Sun. So, back and forth we went with work on benchmark du jour and then,
But I think that was the
X
right
came
answer
around
at the
and-
time. It took a long time for companies to build up enough real world, realistic load simulation that
Yeah,
you could do
yeah.
anything but go after a benchmark.
Yeah.
I mean,
Well,
SQLite's
it's still a problem.
proprietary data isn't the code to SQLite. SQLite's proprietary data is their giant set of examples of how people use SQLite, so you know what's actually the use case to target.
That's interesting. Yes, that makes sense. Yeah.
Someone was saying something.
Well, I was just saying that having a real and representative set of benchmarks to optimize on is still an open question.
You need to have something to point you somewhere, and you're going to pick a benchmark as whatever your goal in life of helping people is.
Yeah, but then, so like when you have some set of benchmarks, you work on them for long enough time, you would optimize most of the low-hanging fruits, and then you kind of overfit your system for the set of benchmarks you have.
Yes.
And if it's representative, cool, then you'll help other similar workloads as well. But if it's not, you just overfit it for the set you have.
Yep.
And now, how to make sure that the set you have is actually a good one? I don't know.
Well, it's really easy, Archer. All you have to do is have a benchmark that includes JSON, XML,
Oh, God.
YAML,
No, stop now. You're hurting me.
protocol buffers.
Actually, recently we started going after just various serialization, deserialization protocols and just covering this extensively, just because, we found that like almost every application does this because they need to send data over the wire, save it somewhere. So we are optimizing, like we've been working on optimizing Jackson code recently, for example.
Yeah, that makes total sense. Like
The one-
Hotspot does.
Speaking of low-hanging fruit,
The one that
Hotspot does
shocked me with
provide-
serialization, deserialization was I worked on a few systems where when the request came in, you would go through a pipeline that was like whatever, 6, 12 services deep, and they would each add something to the request, and then the request would get sent back. And it turned out if at the very beginning you allocated an object that was the size of the response and sent extra zeros between all of the services, just the fact that you could allocate one buffer, fill it from the network, add your piece, move the whole thing out, ended up being faster than a buffer that was slowly growing each time it went. And I was just like that shocked me. I figured there's network latencies in here. Allocation time can't possibly matter, but
yeah, maybe. I mean, networks have gotten stupid fast if you set yourself up right. And in and out of the network card and never leaving the network card may be very competitive with main memory latencies.
most people don't ever see those cards now. That's the thing. The cards that Amazon uses are not the cards you can buy. So you're talking 100 plus gigabit Ethernet cards with processing on card, and they dual port them on the card, and so you're basically I can't remember the article, but you're basically within 3 hops of any server in a data center. And that includes switches and routers. So and the hop latency it's almost zero at this point.
400 microseconds, basically.
No, it's less. Oh wait, no, it's less than that.
I
Yeah, it's a
believe
maximum maybe of 400 if you have to do 3
400
hops.
microsecond inside the kernel inside.
Yeah,
Maybe my information is still. I think it's roughly that.
So I talked a lot with Martin Thompson and Disruptor and doing high frequency trading and doing exchanges, and he uses these kinds of network cards all the time. So it's fun conversations, but yeah, don't.
Was it a specific network card? I was
He
talking
was
in
using
the general case.
we call it Solar on Flare or something. It was a funny name card you never heard, and he could do incrementally byte by byte as they appeared over the network at network speeds, reading the bytes showed up and doing decisions. Like a lot of the high frequency trader games were fastest wins, and a lot of orders were put out that you were going to cancel nearly all of them, but you were looking for a response from the server. And after you got far enough in the packet you were going to get, you already knew it was time to cancel the following orders. So you had read 10 bytes in, had sorted your response data so that after 10 bytes, you could tell that this was a response for this job. You went to his table on the card and he said, send this packet back, which was cancel this order and put a new one out at a different price point. And this was all being done on the card with the network as close as possible to the wires, like stupid stuff. Yeah, right. It's like crazy.
How do you program that? I mean, you're clearly not using socket.io at that point.
No, they were writing Java and pushing down like program state and do this, do that, and filter code into the card.
They were running Java on the network card.
I'm trying to remember. He totally was using Java at some point in the stack, and I don't know what he pushed down onto the network. I don't know that he was pushing Java down on the network card. May not have been, but there was a lot of Java floating around. That was the reason he and I talk. I mean, because we're high throughput, high performance, low latency, blah blah blah. But also, there you go. It has a C API, so he must be pushing C code down. But he had Java wrappers elsewhere that he was talking. He could talk at Java with Java to the network cards. I want to say memory directly, like it was a direct byte buffer.
Yeah,
not a memory mapped direct byte buffer, not a Java heap.
Right. And I thought having Java in the YubiKeys was a dense environment.
Yeah. Oh, so Matt, when I was doing, back in the day, I ended up talking to probably half of the trading shops in Chicago and a quarter of them in New York City. So 40 or 50 trading shops. And half of the guys I talked to were using Java and wanted to have their better startup time, is what Arthur was going after, or lower latency, or just understand what the fuck was going on so they knew. And the other half were using C, but wanted to know why the Java guys were using Java. So they had to know what the competition was doing. And the reason for Java is that you could flip algorithms much faster.
You talked to CME, didn't you?
Yes, I did.
Those fuckers are the biggest time wasters ever.
Well, I talked to a lot of folks in Chicago. There were some as well. But
the CME guys are like, yeah, we write everything in C.
There were people who did only touch C for sure, and there were folks who did Java because they could flip algos faster. They were more stable. It was quicker to debug and diagnose, so you could flip your algorithm faster.
I can't name the bank, but there was a certain bank that was the largest bank in this particular type of trading, and
I can name some banks in that.
Yeah, and they were all Java, and I was like, really? Like all Java? Like I knew you used Java, but like they're like, oh no, for the algo trading, for the time-based algo trading, we do all Java. They're like, we occasionally hit a GC and miss a couple opportunities, but it doesn't matter, because if we miss it, we're not losing anything. We're just not gaining something.
Yeah, if you set yourself up right, you can be there. Yeah, right. Yeah.
And they said, the way we've tuned this is just as fast as if we had, written it in assembly, except, we'd never get it to market if we wrote it in assembly or C, right?
That was the argument. Yeah.
I mean, if
And
you
they were
get
too-
out of the market when you start seeing memory pressure and then you get back in after the GC is done, is that really that different than Twitter servers saying, oh, I'm about to do a full GC. I'm going to call the load balancer and unregister from the load balancer and then do my full GC and then register myself with the load balancer again?
Yeah,
Like,
probably.
So
Some of these guys
it's a little
were-
bit different in the
Oh.
speed-based trading though, because they're not their servers. So the exchanges don't allow you to use your own servers. So the servers are provided by the exchanges. The wires are provided by the exchanges, and the wires are all measured to the millimeter. I'm like, this is the,
Yeah.
like, you can't make this shit up. It's so ridiculous. And
fairness is very important when you're in a privileged position over everybody
right.
else.
So you're never allowed to touch the server. Like you probably would never
had-
see the server,
they
right?
had
It's
lots of-
installed for you. Everyone has the same exact freaking hardware, the same length cables.
A lot of
And-
issues where they allowed people to swap servers out that were smelled really bad. So some guy would come in and put a server in that was a giant heat sink and arrange the fan to blow on his neighbor's server on purpose. He wasn't computing anything on this guy. He was
I will
just
neither
blowing hot
confirm nor
air.
deny.
Yeah, on another server in the next rack over on purpose and caused them to get
Yeah.
flaky ass. Shit like this was
So-
going on. Like they would have to have armed guards to follow people in who were going to swap out server boards and computers into these rooms because the guy would silently swap out a cable on a neighbor with a flaky ass cable that would cause him to drop bits and run slower and do weird shit. No sign, anything. And go, oh, it just got so bad. So yes, fine. And these are all war stories I'm getting told at every time I go into one of these shops. Like, what the fuck is this about? Oh my God, well, this blah, 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 blah. And you hear these things left and right. It's like, holy shit.
I'm always amazed by our society where when people need a trusted third party, they use a bank and the banks don't trust each other at all.
And they do not. And they should not, unfortunately.
Well,
Plenty of
what's
history of
hilarious? What's hilarious is it's all a game to them. They love this stuff. And by the way, the guy who's currently at Bank B was at Bank A 3 months earlier, writing the system that he's now attacking from Bank B. So it's a very incestuous industry, and it's like, see you, Arthur.
I
But,
turned down jobs,
Bye.
repeated job offers in that domain because I just didn't want to be that slimy guy. But there was some fucking good money to be made. Hey, see you out there. Well,
That's the trick with technology. You have to get the people with money to pay you to make the stuff that then everyone in the world can use.
Yeah. People with money want you to make more money for them.
Sun has a lot fewer customers than the number of people whose lives have been improved by the existence of Java.
Yes. Sun's great honor, great mistake, great step forward was, they made a cool thing and I'm happy I was part of making the cool thing, and they sucked at making money.
I love my old saying that Sun is the only company to never make money on Java.
Yeah.
Didn't they make like $11 billion over their run or something?
Oh, I
In
don't
terms
know.
of from Java or total.
I was thinking total. My understanding was most of that came from the hardware sales.
Yeah, it was all hardware sales. Yeah. They couldn't make hardware to keep up with Intel. That was the theory was their hardware started out better than Intel, quickly got behind, couldn't catch up. So, Java was, hey, we'll get the programmers to write code that'll work on both Sun hardware and other hardware, and then we'll solve the software problem, which basically kind of worked. But we have to have hardware that's competitive, and that did not work.
Yeah, but Sun just didn't understand the idea of making money and selling things for more than what you paid for them. That was a fundamental issue in their business
Yeah,
planning.
maybe. Yeah. I didn't pay attention to that when I was there. I was busy doing.
I won't name any companies, but there's a company I used to work for that really understood the idea of making money and spending less than you brought in.
And Larry, thanks you very much.
I am neither confirming nor denying, but one of the products I managed.
So you've got to include the decade so you know which Larry. There was a different Larry later.
One of the products I managed delivered $2 billion a year in profit. That was one product.
I assume that you did not see but the tiniest fraction of that.
I will neither confirm nor deny that they paid me.
And it's also probably not a Larry from Perl, right?
Larry Wall? No, I don't think so. All right. I think we're running downhill here, and it's reasonable to cut off at this point. So anyone else, new topics, or I'm gonna declare victory here.
I was just going to say, I've got some fun stories of performance where I found a performance bug that was causing a service to need a third more servers than it actually was supposed to. And the bill dropped by like $60,000 a month for running that service. So I got an $100 gift card as a thank you.
Yes, you are loved, sir. Oh, Twitch. Yeah. Yep.
That's a good story. I like it.
Yep. Fine. All right. Engineers and making money. That's a thing, but not for today. Okay. Till we meet again. And more on overloads and Discord at a future time.